Welcome in. We're going to start a new module and it is on probability. And so we just finished talking about like experimental design and sampling, and then before we had talked about data visualization, right? So how does this fit into the overall picture of the course? And so remember that the overall goal of the course is we want to imagine that we have a population and we want to take a piece of that, which we now know is called a sample, right? So we want to get a sample, we want to do some analysis with that, and then with the analysis in turn, come back and say something about the population, right? And so we haven't gotten to the analysis stage yet, and there's actually a critical link in this arrow from sample to analysis that is related to the underpinnings of the statistical process or the analysis processes that we're going to be using. And probability kind of fits in here. Okay, so just so you kind of have an overall idea of where we're going, but we are going to get to analysis. That's the next stage of the course, but we need this kind of mathematical foundation to do that, and that's where probability enters. Okay, and so the idea with why we need probability is that when we look at the data that we get, right, there's a lot of chance behavior that pops up, or put simply, variability, right? We can take all sorts of measurements of height of individuals, right, and we're going to get a range of values. And so to represent or kind of rein in that variability, that's where mathematics has developed the field of probability to help address that. And the idea with probability is that when we look at kind of an individual result or we think about what's going to come next, we don't know. So it's unpredictable in the short run, but then as we look at long periods of time or iterations of the experiment, everything is very predictable. Okay, so I have a picture of some dice here, so you know, okay, you can roll a die, right, and you're going to get a number 1 through 6, assuming it's a fair die and whatnot. But then so you don't know what you're going to get on an individual roll, but you could say, you know, if you repeated this hundreds of millions of times, you're probably going to get a one about 1 out of every 6 times, right? So just so you have an idea of what the chance behavior is. Other examples are, you know, when playing the lottery ticket or the lottery. So if you buy a ticket, you're probably not going to win. Chances are actually extremely low. But then in the long run, if you were to buy many lottery tickets, you would likely win at some point. Okay. But this idea of chance behavior gives rise to what we call probability and randomness. Okay, and so these are some formal definitions. I'll say them verbally twice each, and then we'll kind of move on with our life. So random is just individual outcomes are uncertain. Individual outcomes are uncertain, but there's a regular pattern to outcomes or regular distribution. Okay, so individual outcomes are uncertain, regular distribution, or the outcomes occur with a regular distribution. Okay, probability is the idea that any single outcome is a random phenomenon, but again, we want to look at the overall probability of an event being what would occur in a very long series of repetitions. So probability is that long-term behavior, or again, a random, the probability of an outcome is the proportion of times we would see it occur in a very long series of repetitions. Okay, and there's 3 probabilities that we're going to talk about. This one is most oftenly associated with mathematical or theoretical. It uses different names. So just so we're aware of that language. Okay, so then you don't always get a 1. Why? When you roll a fair number die, right? And that is just because this idea of variation, right? So in 6 rolls, there could be a lot of variation. You might get really lucky and you might get all ones. You might get 1 1. You might get 3 ones. We don't know, right? And that is to say the same thing with even 600 rolls. Like we would need to see in the long term behavior in the long run. So as number of rolls or repetitions of the experiment approach infinity, then we would see this probability occur, okay? Or if we say the probability of getting a 1 on a number die is 1 out of 6, then we would see that happen in a very long string, okay? And there's two other types of probabilities that I want to briefly touch on. We're not going to stress them at any point, but I just want you to be aware, okay? So in the graphic above here, it says the chance of being selected on the price right is 1 in 36, right? So that's kind of your chance for that. Okay? But then you're like, well, okay, so even if I don't attend the Price is Right, I have a 1 in 36 chance of being selected. Well, not really, right? Because that's where personal probability comes into play. So it's using your own perspective to influence that probability. So, there's a certain chance that you're going to get in a car accident. Well, if you're a very safe driver, following all the rules and being very mindful, doing hands at 10 and 2, you're probably not going to get in a car accident as frequently as somebody who's, texting on the phone while driving and drinking coffee and doing X, Y, and Z bad habits while we're driving. So those probabilities can be influenced by personal behaviors as well. And so that might give rise to this idea of personal probability, which is just simply to say, um, expressing your own individual judgment on how likely the outcome is. And again, this is going to be if you think about it as a decimal, it'll be a number between 0 and 1. Okay. The other type of probability that that we actually are going to see is the idea of empirical probability, and that is computing the probability based on data. So the first definition that we had of probability didn't have any data in mind. Now, when we talk about empirical probability, that is once we see the data, then we can compute the probability. So if we happen to, roll a die a certain number of times, then we can compute the probability of a 1 based on the total number of outcomes. Okay? Just so you're aware of that. All right, so to simulate empirical probability, let's flip into Excel and simulate coin flipping. So I've set up Excel to count through a number of flips, and then I use that rand between command that we've seen before to simulate a count or a flipping of a coin. And so I said 0 is tails and 1 is heads, and here I have the probability of a heads calculated. And right now for this sample, I have a 60% chance. So what I'm doing is just counting up all the ones and then divided by the total number of flips I've done. So I think this one I've done like 50, yeah, 50 or 49 technically flips, and so I get this probability. Okay, and then you can certainly resample. I'm just hitting on my computer FN F9 or just F9 on your computer, and so you can see the probability is going to change based on the sample. So this time when I got the sample, it's exactly what I would expect. 1 out of 2 outcomes, I should get 50%, but then we can see just by the random process of flipping, given that I don't know each individual outcome, the probabilities are going to change. Okay, and if I were to, extend this much further, you can see the probabilities get as I flip through them now. Okay, I did something on the order of 3,000 flips. We're getting much closer to 0.5, and that variation is much less. Okay, so again, probability for us in mathematical sense is what we expect to see in the long run. Empirical data is what I'm calculating here. So total number of events over the total number of events of interest over the total number of events, and then the personal probability is maybe there's something that I can do magically to influence the outcome, but most likely not in this context of flipping coins. Okay, so be aware of those three types of probabilities and just what the definitions are.